This is part 2 of chapter 3, Petroleum and Synthetic Materials. We're going to discuss the energy sources. We have three major energy sources for non-renewable energy, which are petroleum or crude oil, coal, and natural gas. If you look to the right, we can see that we have two types of energy. Renewable energy, energy which can renew itself, for example hydropower when we use water to produce energy, solar energy when we use sunlight, or wind energy when we use the wind to produce energy. In this unit we're going to discuss only non-renewable energy sources, so sources which we can use once and they disappear once used. For example, fossil fuel oil, petroleum, natural gas, and coal. Now, for all these energy sources, non-renewable energy sources, we use them mainly as fuel. And when we say fuel, we mean any substance that is used to produce energy. This is their major role. However, they have a second role, which is to be used as raw material to produce other compounds. For example, plastics and other types of compounds can be produced from fuel, from petroleum, natural gas, or coal. We're going to start with coal, one of the oldest fuels used. It is a complex mixture, so it is formed of different elements. The main elements present in coal are carbon, hydrogen, oxygen, nitrogen, and sulfur. So we need to memorize these elements present in coal. Its main purpose is to be used as fuel to produce energy. The second type of non-renewable energy source, which is the cleanest source of energy, is natural gas. It is present in underground wells. So when we dig wells underground, we sometimes find natural gas alone, sometimes we find petroleum and natural gas together. So if we look to the right, we have non-associated gas. This non-associated gas is a well that contains only natural gas. If we look to the right, we have associated gas, so it is a well that contains gas and oil together. Natural gas is composed mainly of two compounds, methane. 80% of natural gas is methane, and 20% of natural gas is ethane. As before, used mainly as fuel. Petroleum, and when we say petroleum, we do not mean the fuel which we use in our cars. Petroleum is the mixture which we extract from underground wells. It is a viscous or thick liquid. So it is a thick liquid. It has many different hydrocarbons in it. So it is not made of only one compound. It has many different compounds in it, hydrocarbons. Before using petroleum, we have to refine it. We have to process it. And when we say processing or refining of petroleum, we mean separating the different components of this mixture. So since it has many different compounds in it, we need to separate them from each other before being able to use them. Where do we refine petroleum? Petroleum is refined or processed in oil refineries. So the factories where we separate the components of petroleum, we call them oil refineries. So the process is we extract petroleum from underground wells, we transport it into oil refineries. At oil refineries, we separate petroleum into its different components. As before, petroleum has two roles: an energy source or fuel, and it could also be used to produce plastics. This is an oil refinery or a petroleum refinery in the picture to the right. The process where or by which we separate petroleum or its components is called fractional distillation. So we take the oil after being extracted into a refinery. We perform a process called fractional distillation. The separation is based on different boiling points. So this process is a physical process. We need to memorize. Fractional distillation is a physical process. How do we separate the components of petroleum? By using different boiling points. We know from before that any hydrocarbon, as the number of carbons increases, the boiling point increases. This is in the picture to the right a fractioning tower. So if we go back here, these towers at the refinery are actually called fractioning towers. What do? They separate the crude oil or the petroleum into different parts. These parts we call them fractions. So if you look here at the figure, crude oil enters the tower at the bottom. We extract from the second side of the fractioning tower the different mixtures or the different compounds found in this petroleum. Now if we look at the figure, the fractioning tower has different temperatures. So the temperature in the fractioning tower is not the same. We start at a very high temperature at the bottom, about 350 degrees, and as we go up, the temperature will decrease. So at the bottom we start at 350 degrees. As we go up, the temperature keeps on decreasing until we reach the top of the tower where the temperature is 25 degrees Celsius. This process, we said, separating the petroleum into different fractions, is called fractional distillation. This device used to separate petroleum is called a fractioning tower, and the fractioning tower is present at a refinery. So the temperature is highest at the bottom of the fractioning tower and coolest at the top. Now if we look here on the right, we can see that we get now different types of substances. We start with bottled gas. We get it at the top. This is gas we use at home in ovens. Below it we find petrol or the gasoline which we use in cars. Below it we have kerosene. Kerosene is the fuel used in jet engines in airplanes. Below it, diesel used in trucks. We have lubricating oil, fuel oil, and residue which we use to pave roads. So how did we separate these different components? We said based on the boiling point. If you look under each component, we have the boiling point for each one. So residue has the highest boiling point at 600, lubricating oil boils at 300, kerosene 175 to 325, petrol at 40 to 255, and refined gas less than 40 degrees. So we separate these components based on boiling points. The component which has the highest boiling point will condense, turn into a liquid at the bottom, and we get it from the right as a liquid. The components with lower boiling point, let's say petrol, they condense at the top, so they turn into a liquid at the top of the fractioning tower, and we get them to the right. Finally, gasoline. Gasoline is the fuel used to power car engines. So the fuel which we put in our cars is called gasoline. Now, if you look at any gas station, we have different types of gasoline. We have 98 octane, we have 95 octane, we have 91 octane, and we have 87 octane. What are these numbers? It is actually a measurement of the quality of the fuel. So the best fuel is 2,2,4 trimethyl pentane. It is an isomer of octane. It is an excellent fuel. We gave this fuel an octane number of 100. Since it is the best, we gave it an octane number of 100. We compare all other fuel types to this mixture, 2,2,4 trimethyl pentane, and we give them a relative number based on their quality. So 87 octane is a mixture of fuel that has 87% similarity to 2,2,4 trimethyl pentane. 97 octane is 97% similar to 2,2,4 trimethyl pentane. If you look at this isomer 2,2,4 trimethyl pentane, we can deduce that it is branched. Trimethyl, so we have 3 methyls. 2 of these are on carbon number 2 and 1 is on carbon number 4. So it is not linear, it is branched. There is a rule that says as the number of branches increases, the better the fuel is for a car. So as the number of branches increase, the smoother the fuel will burn in a car engine and the better it is for a car. So this is the last part of chapter 3, petroleum and synthetic materials. Thank you.